This conference will now be recorded.
Hello, everybody. Thank you for joining us today. Jordan Girth here from the National Weather Service Office of Observations for the Satellite Book Club Seminar Series. This is session number 65. We have a great presentation today titled Satellite RGB Composite Imagery and Applications, a COMET lesson. The presenters are Patrick Dills, meteorologist with the COMET program, and Bill Line, physical scientist at the Regional and Mesoscale Meteorology branch of NESDA STAR. Our discussion after the presentation will be facilitated by Frank Olsheimer, Sue at the NWS Forecast Office in Columbia, South Carolina. Just a few reminders before we get started that the session is being recorded. There'll be an opportunity for Q&A after the presentation, and we are always looking for future presenters. So please get in touch with us if you have an application you'd like to share with your colleagues in the field. The training team can help create training materials that may be unavailable. Contact Brian Mata for information or questions regarding that. I'd like to thank our TARS team, particularly Kashad Bowman and Lee Byerly, the Office of the Chief Learning Officer, and GOES-R and JPSS programs for their support of the Satellite Book Club. One reminder before we get started, this is something we mentioned last week, is that the GOES-R program and NOAA Center for Earth System Sciences and Remote Sensing Technologies invites you to join them for the inaugural GOES-R Hackathon, September 24 through 26. Students from 6 universities will compete in a weekend-long event to develop solutions to using GOES satellite data. So we're seeking mentors, and if you'd like to volunteer for the event, happen to be available, I believe it overlaps partially with the weekend, so that may be challenging. Email goesr.hackathon@noaa.gov, and someone from the committee will contact you. You can see everything there in the chat room. All right. Moving on to the presentation of the day, just some brief introductions. Patrick Dills has been a meteorologist and scientist with the COMET program in Boulder for 26 years as a project lead and training content developer. Patrick provides guidance and satellite remote sensing expertise to COMET courses and lessons that focus on satellite capabilities for operational forecasters as well as other users. Bill Line is a physical scientist at STAR-RAM-B in Fort Collins, Colorado. In his role, Bill conducts research into the detection of various mesoscale phenomena using NOAA satellite data. So Patrick and Bill, welcome to the Satellite Book Club today.
Thank you, Jordan, and welcome everyone. And again, thank you, organizers, Kashad and Jordan and others, for giving us the opportunity to add a little color to the day, hopefully, and talk about one of our newest med-ed lessons on RGB applications. So I'll start off with the presentation, a little bit of an overview of the process and how we got to building a lesson. And second half, I'll turn it over to Bill, and he'll be presenting some examples from the lesson. Let me jump right in here. Yeah, so let's just start out with the process. This is something that we go through with every COMET lesson, even before we get to talking about instructional design and defining and developing the content. What are some of the reasons for creating this lesson? Well, we typically talk with our sponsors, in this case, Weather Service, forecasters, SUS, GOES-R program, JPSS sponsors, to try to identify a training gap. And one thing that came up was a sense that there was some underutilization of RGBs in the forecast process. So starting with that, some of the reasons really for creating the lessons, we also have RGBs, which are new to a large share of forecasters, especially now with availability of all the RGB products we see, not only in AWIPS, but also online, coming from GOES-R and JPSS. RGBs provide exceptional value to operations, and on our SME team, which included Bill Line, Carl Jones, and Kevin Hugh from Duluth. So this really encapsulates, I think, what we hear from some of the experienced forecasters. So RGBs excel over single band analysis because they can offer much more information in a condensed, easy to interpret image, cutting down time, spent analyzing information used for decision making. And additionally, effective RGBs offer the user added precise context to trackable meteorological features, which may be hard to view or may even be invisible through a single band analysis. So it's this precise and timely analysis of information leading to better decision support that makes the RGB composite technique operationally relevant. So I think Carl did a really nice job of capturing that, and we wanted to include that in the presentation. Then looking at the goals, lesson goals, overall we wanted to increase the effective use of satellite RGBs among forecasters and other interested users. Second, focus on operational meteorologists, along with others who need to expand and optimize their use of RGB products in the forecast process. And then also reach out to the international audience that's interested in learning how to more effectively select and apply the GOES-R and JPSS RGB satellite process products and forecast process. Then we move on to, we've established the need for the training, determining the scope and learning objectives. And this is to build that framework even before we get to content development. So the team identified forecast challenges, situations, and applications where the RGBs were known to provide some added value. Second, the team described the most commonly used RGBs for forecast applications, and the team selected 7. There are more, but we had to prioritize given the amount of time that we had for the lesson. And then the RGBs should be available in AWIPs, either operationally or experimentally. We also recognize that many RGBs are available online, including the ones that we show in the lesson. And then next step was to match these RGB products to given a forecast problem or situation. And the team came up with prioritized 4 topic areas. And these include surface feature identification, cloud detection, characterization, convection, and dust. There were obviously are others, and we just, again, giving the amount of time for the lesson, and that some of these other areas that we had tackled in recent COMET lessons, including for fire weather or volcanic ash and dust, these really rose to the top amongst our SME team. And then we want to be able to use the RGB capabilities or the added value to ID features in the imagery. And this is something we will see in the lesson. So why did we choose these 4 applications? Well, again, the RGBs provide the most added value for these applications over traditional approaches, such as single band interrogation or simple image differences. And each of the 4 application topics also map to a variety of potential analysis challenges or tasks, forecast impacts. And they include, you can see the laundry list here, interpreting various surface features, identifying low clouds and fog, different types of cloud analysis, low clouds at night for aviation, the pre-convective environment, and that includes looking at the microphysics of cloud top and trends, and then detection and monitoring of blowing dust during day and nighttime. So we can see how each of the 4 areas branches out into some of these subtopics or identification tasks. And I just want to briefly touch on the instructional approach. We wanted to provide an overview of the product applications and capabilities, which we do within the lesson throughout, provide lots of opportunities for practice interpreting the products, again, to increase the forecaster familiarity and increase this potential integration into workflow. So we have 13 unique cases and examples embedded within this lesson that all provide interactions and that focus on some aspect of an operationally relevant concern or forecast problem or even analysis challenge, if you will. Getting to the actual layout, this is the very first, the top of the screen you see when you enter the lesson. We have a couple of different ways of navigating to the content. And this is just a table representation. So you can see each of the 4 headings are the application topic areas. Beneath those are specific types of analysis that we determined would be interesting or important. And those are mapped directly then to the RGBs. So if I want to, I'm simply interested in burn scars, I can go to surface feature identification, click burn scars, which is linked to the day land cloud RGB, and I can jump directly to that content. So that's one way of navigating to a particular piece of information of interest. Another way is this geographical map that's clickable and shows the distribution of the 13 cases that we have. And underneath the map, again, are the 4 topic areas, and under each, the particular identification challenge listed. And again, these are all clickable, so this is another way of getting to the content. When you see this, another thought that we had is this lends itself to expanding what we might want to do in the future with these. So if we added other cases in other geographical locations, we might be able to do this with this type of navigation approach. So here's just a brief example, and before I turn it over to Bill, of how the approach, how most of these examples work. We start off with an example of, say, imagery that forecaster should be familiar with, in this case, just visible. We ask a question right up front: what are the features that you can identify in this animation? In this particular case follows a snowstorm in southeastern Colorado. So we're seeing snow cover, probably a mix of cloud cover, different types of cloud cover, and the animation will show that. And then next, we want to go to a relevant RGB. And again, we'll just animate this. And again, provide an interaction. Now we have specific features. We want them to click and drag to a corresponding feature in the imagery. So on the next screen, you can see on the left is what would look like something that I did very quickly: drop labels, as many as you like, as often as you like. This is when you're completed this. On the right is some expert feedback that includes annotation, and then some discussion about why this product works the way it does, what are its advantages or maybe disadvantages. The other thing we like to cover occasionally, there's a complementary RGB. In this case, if we're trying to identify, separate cloud cover or low cloud cover from snow on the ground, the day snow fog product that you see toggling with the day cloud phase discrimination RGB highlights the low cloud, the water cloud features. And so we talk a little bit about why that is, and again, how do the 2 RGBs complement one another, and what are their particular strengths? So at this point, I'm going to turn it over to Bill, and he's going to walk you through an example in each of the topic areas. Take it away, Bill.
Thanks, Patrick, and thank you everyone so much for joining today. I'm happy to speak on this topic. As mentioned, we focused on these 4 application areas with several examples, varying examples under each application. And I'm just going to go through really quick through an example from each application from the module. We have the surface feature identification section, and of course there's a few RGBs that could help in this application area. For this module, for this example, looking at the daylight cloud RGB, which is incorporating some near IR and VIIRS channels to give you an idea of vegetative state, rivers, lakes, and even clouds. And in this particular example, asking a forecaster to use their knowledge of the ingredients of this RGB to identify where the burn scars are. And if you think about it, a burn scar, you're going to lose your vegetation, so you're going to lose your green component, so or your veggie band component, so you're going to be left with more of a brownish red looking feature. So then you, in the module, ask the forecaster to identify those areas, and then they can see the example. And this is actually a neat example because in the orange you see the burn scars, but also you had lava fields as well in eastern Idaho, highlighted there in black. And those are a little darker than the burn scars due to the fact that they have absolutely no vegetation. So they're going to have a low reflectance in those channels. And within the surface feature identification section, there's also a winter scene classification examples differentiating snow, melting snow, and ice and melting ice, and low clouds over snow, examples like that. So really great section in showing the value of RGBs over traditional techniques for identifying features like this. And so moving on to examples from the cloud detection and characterization section, we didn't forget about our partners up in the Great White North. In Alaska region, we have some VIIRS examples. Of course, Alaska have heavy utilization of the RGBs applied to the VIIRS instruments. This example, the day cloud phase distinction RGB, and what's great is a lot of these examples are operational examples straight from the forecast offices. So this is an example provided by the Juneau Forecast Office of how forecasters utilize the day cloud phase distinction RGB to monitor low cloud evolution within the inner channels around Juneau, Alaska, and how they would impact the various TAF sites. So of course, using traditional techniques, the scene would be a whole lot of white and various shades of gray. However, the RGB, this is actually my favorite RGB given its many uses. It helps in this scene to differentiate the snow cover in green versus the low clouds in cyan and the upper clouds in yellow or red, allowing the forecaster to track the intricate details of the low clouds evolving within the inner channels near Juneau, Alaska. Moving to a nighttime example, my second favorite RGB, the nighttime microphysics RGB. And with many of these examples, we like to compare it with the traditional techniques so that a user could understand, what are they getting out of this RGB versus what they used to use. And in this case, comparing it to the fog difference. And exemplifying how with the RGB, you could not only differentiate water clouds from ice clouds as you could with just the fog difference, but by combining it with the IR single band imagery and the split window difference, you're able to further differentiate your very low clouds and likely fog versus your low to mid-level water clouds, and also your ice clouds, splitting that up into more high thin cirrus ice clouds versus high thick or convective ice clouds. And back to the day cloud phase distinction RGB now being applied in a convective example. Again, one of my favorite applications of an RGB in the GOES-R era is using the day cloud phase distinction RGB to identify areas of glaciation and convective initiation. And in this example, of course, you could see the evolution of water cumulus clouds from the cyan aqua colors to green, indicating you're glaciating, you're losing your blue component or your 1.6 micron band as those clouds are developing ice, and you're absorbing energy at 1.6, so you're left with green and the more highly reflective vis band. And as those clouds continue to grow and cool, you're introducing that red component as your IR band cools, and you're transitioning then to yellows and reds, indicating glaciation and convective initiation. Again, it's something you wouldn't see with just the vis alone. And then in the module, you're asked to kind of highlight various stages of convective growth. In the circle, where you have the most robust convection, you have the development of those reds and yellows. In the square, you're developing orphan anvils and not quite deep convective initiation. And then to the southwest of the scene, you're developing those towering Q and the green colors and the cloud tops. You're just starting your glaciation. So great example showing the value of the day cloud phase distinction RGB for a convective situation. So playing that out so you could see the development of deep moist convective initiation. And then again, we really like to compare with the traditional techniques and the individual ingredients going into the RGB so that a forecaster can really gain a better understanding of why that RGB appears as it does. Here's a nighttime convective initiation example. Maybe one of my favorite examples from this module because I think it's an application that's probably underutilized in the field, is using the nighttime microphysics RGB to diagnose convective initiation. This example is from Carl Jones up in the upper Midwest. The first step would be identifying your development of cumulus clouds as you develop cumulus cloud looking structures in a pale cyan color. That's telling you that you're introducing green, so you're developing a water cloud per the fog difference in the green component. As that pale cyan would transition more to a red color, that's telling you that you're losing your green because you're developing ice, so your fog difference is decreasing, so you're losing your green. It's converting more to a red, and again, looking the appearance, the shape, what would look like a cumulus cloud that might be glaciating because it's turning red, you're losing your green. And then as you play the animation out, it continues to turn red, and we actually have the IR overlaid on it, and some best practices, I guess, interweave throughout this module, in that overlaying things like IR in places where you're not really getting much information from the RGB. Your deep convection is just going to appear red, so you might want to overlay the IR to add info there. In the last example, we have a dust section. We do look at some RGBs, but also in this example, GeoColor. First, showing you the VIIRS from this dust example, how especially during the high sun angle time of day, you're not getting much information from VIIRS alone, and you're not really differentiating dust from smoke. But when you introduce true color imagery, such as what you have in GeoColor, you're much more easily able to identify blowing dust during the day, all parts of the day, especially with the low sun angle, but also more easily able to differentiate smoke from blowing dust. So I'm going to wrap it up real quick here. This module showed the exceptional value RGBs provide to NVOS operations, especially in those 4 areas. We include a variety of diverse examples showing the value of RGBs, and I definitely recommend you going into the module and looking at these examples in more detail. There are a few upcoming lessons coming out from COMET you should look forward to. There's a GLM lesson coming out shortly, as well as a banded snowfall lesson. And I also have listed some more of the recent lessons from COMET. So Patrick and I thank you so much for joining today, and you can email us with questions or ask any questions now. Thanks a lot.
Thanks a lot, Pat and Bill. Appreciate that presentation. A lot of good things in there. I agree that RGBs, while they're slowly increasing in use, could probably use a little bit more. We've got a great discussion section, Q&A coming up, but I have a few notes I want to make first. First, next week, our presentation will be from Caitlin Rutt, a meteorologist in Amarillo, Texas, and she'll be discussing utilizing the NuCAPs for supplemental observations in a convective environment. Another thing is that while you're going through this, please fill out the survey form. The link is posted in the chat, so we can get some feedback on how this particular session worked for you and any feedback you might have. And again, if you have any questions at all concerning the Tower S folks, please contact Lee Byerly or Kashad Bowman for questions about the Satellite Book Club, what we're doing and any configuration or satellite product information. So the questions that I've got, do we have any questions yet in the, okay, here's a comment here and a question from Tim Schmidt. Great talk. Do you have plans to combine RGB with L2 info? For example, show the cloud phase distinction RGB, but underneath the readout could be a derived product such as cloud phase. Some examples are shown on a link that Tim has provided in the comments.
Yeah, Tim, I think that's a great application of the level 2 info underlaying the level 2 product, as you said, for example, cloud phase under the day cloud phase distinction RGB, so that when you're getting the readout with the mouse cursor, you can get additional information, not just the colors from the RGB, but the actual classification from the level 2 info. That's not included in this module, but certainly could be the source of future training and something that would recommend forecasters try out.
Yeah, I know from personal experience, I find some benefit in putting the cloud top height, cloud top temperature underneath when I'm looking at the VIIRS IR sandwich product, so that I also get a readout on what the algorithm is telling me for the cloud top height and temperature. Next question. Patrick, I bring this up to you because you started the presentation. What if the field identifies a case that they think would be a good addition to this training? It looks like the way you've got it set up is reasonably scalable. What process would there be for field forecasters to work with COMET to potentially get those additional cases added to what you're doing?
Yeah, thank you, Frank. That's a good question. And we frequently have discussions with our sponsors, knowing that this is sort of a stepping off point. And in many of our lessons, several years ago, we actually had a very foundational RGB lesson on what just defining what RGBs were. Now we're at the point we're talking about applications. So the next step would be to develop some additional capabilities, add additional cases. So each year we determine what some of the training priorities are. And if we hear from the field, we hear from the sponsors that are their interest to build on this, then we would engage as many interested parties out there who would like to contribute and be part of the group, so we can then actually define a project. So I would say it's really a communication that we have to continue with our sponsors. And if there is anyone who would like to send us, a short email saying, yeah, this is great, I'm interested in contributing in the future, keep me in mind, we'd love to hear from you.
Hey,
Okay.
this is Bill Schoberg, JPSS program. If I could say a few words about that.
Yeah, please go ahead, Bill.
Okay, so number one, we should not, no one should feel that they need to wait to have a particular case included in a COMET module. Okay, so we have created with Bill Line is a big part of that, and certainly the Brian Mata with National Weather Service have created what I consider to be a nimble response to providing blogs or quick guides or just stories about the application of various capabilities to real world events. So if somebody has an event and if they have used RGBs in that event, let's get that out. If they have an event and they would like to have someone else use RGBs to look it over, we have a training initiative that I'd be happy to kind of put that on the table and see if somebody can help out. So these particular modules that COMET produce are pretty extensive and obviously well done. But I'm not sure you can just stick an additional audio video part to a particular module very easily or very quickly, but we don't have to do that. So my thoughts.
Yeah, I certainly agree with the blogs, and I've actually talked with Scott Lindstrom, and we've gone back and forth over the years on a couple of interesting cases that things popped up that he's been able to put on his blog as well. I just know from my forecasters sometimes they like what they get out of COMET. So, maybe it's something that it starts as a blog and then potentially works its way into that. But, I've had forecasters ask me, I've got this neat case, what do I do with it? And so obviously COMET is one of the possibilities to do that. And we've got stuff in a lot of places, but it's always good to keep that in mind.
Well, let me just add, Frank, and thank you, Bill, for chiming in. Each the examples that we incorporated, I think most, maybe even, pretty much most of those did appear in blogs. And as Bill Line was talking to, you see a different type of discussion there, a different type of presentation. And we make every effort to link also out to those within the content or within our resources section. So one of the easy things that we can do is actually add references, add links to additional blog entries or blog sites. So in this case, where there is a blog entry for the example in the lesson, we link out to that directly, but we also reference the blog as a whole, as a place to visit something that may have come out very recently.
Okay, great. I've got another question that kind of takes a different angle, and that is, what are your thoughts on forecasters modifying the RGB recipes and AWIPs on the fly? There's obviously, it's not a quick push button, but there's obviously ways out there to modify the look of these RGBs based on playing with the different colors and stuff. And I want to get your thoughts on the uses and the caveats of doing that from a field perspective.
Yeah, I think this is Bill. Something we've talked about before, and I've given a presentation in some venue about it before, but I think if a forecaster does it responsibly and does it in a way that makes sense, it's fine. For example, an RGB like the day cloud phase distinction as you're around sunrise or sunset with the low sun angle, I like to and recommend decreasing the max value of those reflectance bands so that you're drawing out and the image more. It's not getting washed out in the red of the IR. Things like that, I think that doesn't really change the meaning of the RGB, and it just makes it more effective in situations where its value is decreasing, again because of maybe things like low sun angles. So I think if it's a forecaster that knows what they're doing and they have the training, and I think there's some blog posts and training on that topic, I think it's okay.
Okay, thanks. Let me see if there's any additional questions from the field here. Anybody else have anything to ask? Just pop it into the chat box.
I'll ask one question if there's nothing else.
Yeah, please go ahead, Jordan.
So Bill Schoberg talked a little bit about JPSS, their specific RGBs, the spectral bands are a little different. What is the thought about using RGBs between multiple different satellites, particularly that have a slightly different set of spectral bands?
I think, you know, some of the RGBs transfer, you know, almost, you know, smoothly if when the channels are the same, such as day cloud phase distinction RGB from instrument to instrument. The RGBs that are maybe different, well, such as the new Snowmelt RGB developed at Sierra that employs bands that aren't available with ABI but are with VIIRS. I think it just takes additional training, development, and especially working with those users that are employing those RGBs, especially, you know, Alaska users that are getting heavy use of VIIRS, integrating the users into the development of that training. So I think, you know, the main action is to make sure that that additional training effort's there and that we're sharing examples of those RGBs.
Okay, got another question for you. Can you comment on how RGB information is made available to forecasters? And will the additions of the new VIIRS M7 to M16 for NCC contribute to what is made available to them?
Yeah, Tim, there's, as we mentioned, training, but I think with this respect that the quick guides are some of the most valuable training to forecasters, and I think all forecasters know where to get the quick guides. There's a quick guide, just 1 to 2 page summary for each RGB that really gives a great brief rundown on the components of the RGB and the meanings of the colors. And then of course there's expanded training beyond that. So I think that's where the forecasters get their RGB information. And with the addition of the new VIIRS bands, again, same thing, there's training. I think though the focus on that wouldn't be until we see those VIIRS bands maybe appearing in AWIPs. I think in Alaska, they already have that, so they have the training and the knowledge there. And if that ever comes to fruition, having more VIIRS bands in CONUS offices, then again, it'll be the same model as what we do with the ABI RGBs.
All right, one last question, more to ponder, I guess. You were mentioning earlier about potentially changing some of the reflectance values in the RGB around sunrise and sunset. Do you know if anybody's tried normalizing the inputs by the solar zenith angle?
Yeah, Dan, I remember this discussion at various periods over the last few years. I don't know if I thought at one point we determined that AWIPS wasn't capable of doing that, but I could be wrong. And someone else with more knowledge might be able to answer that. But obviously, if we could do that on the fly and AWIPS have a, you know, that constantly fluctuating through the day, that would be of great value.
All right, I think we're out of questions and actually just about out of time. So I will pass it back to Jordan for any closing remarks he has.
Okay, thank you, Frank, and to Bill and to Patrick. Outstanding presentation. Thank you for sharing that with us today, and hopefully people will check out the COMET modules, many great modules available from COMET. As Frank already pointed out, we continue the Satellite Book Club every week. Next week, no exception, Thursday, September 9th, Caitlin Rutt, meteorologist at Amarillo, Texas, is going to talk about utilizing new caps in a convective environment. If you have any questions related to satellite products in AWIPS, and that includes your RGBs, get in touch with the Lee Byerly and Kashad Bowman of our Tower S team. And you can always reach out there via email or via NWS chat. And more information about next week's Satellite Book Club will be available from the Tower S team. With that, thanks to all of you for being with us today. Hope you're staying well. And if you are off this weekend, I hope you are looking forward to a long weekend. Until next week, take care. Thanks, everybody.